evaluate limits, there are three ways that we can do that. And we're going to look at limits graphically, we're going to look at them numerically, and we're going to look at them algebraically. Now, these two methods, the first two, graphically and numerically, these are estimates. We don't necessarily get the exact answer from here, but we're going to look at the graph, we're going to look at some numbers, we're going to figure out what the limit looks like it should be. It's generally good enough. We're not going to have any crazy stuff that just acts up at the last minute. But this, solving it algebraically, this will give us the exact answer. We're going to do this later. In fact, right now we're only going to focus on looking at a graph and finding the limit from a graph. So if we take a look at this graph here of f of x, we're going to say we want to find the limit as x approaches 3 of f of x. And again, it's really important when we do the limit. We do not care what x is when x is 3. We can see right down here we have a point 3 comma negative 1. So if x is 3, then y is negative 1. That's great. You learned in Algebra 1 or before that how to read a graph. We're not looking at that. We want to look at the whole graph, especially right around this part here, right around x equals 3. What does it look like from the whole graph that it should be at 3? And if we trace this graph up the hill here, here we go. At x is 3, we have a hole in the graph, but it really looks like it should be 2. Y should be 2. And if we come at it from the other direction, as we go down the graph, and we hit x is 3, it looks like it should be 2. It's not 2. We know it's down here. But it looks like it should be 2. And since it looks like it should be 2, we're going to say the limit as x approaches 3 of f of x is 2. Even though it's not, we don't care. We want to get an idea of what it should be. It really looks like it should be at 2. As we get to 3, so our limit is 2.